lesson on the math section of the SAT. There are a lot of different topics that the SAT math section covers. There's algebra, geometry, all sorts of things. But the specific topic that we're going to discuss today is trigonometry. This is something hopefully you've all covered in school, but sometimes it doesn't come up. So I think it's an important foundation to cover because it will appear at least to some extent on the test. So the fundamental thing that I always keep in mind with trigonometry is this phrase here, SOHCAHTOA. SOHCAHTOA. It's just a phrase that you're going to have to remember to effectively do trigonometry. And what this does is it defines the three main, what we call our trig functions, our functions of trigonometry. And what those three functions are sine, cosine, and tangent. So the first letters of each of our SOHCAHTOA phrases represent each of those trig functions, sine, cosine, and tangent. Now, what does that mean, a trig function, a trigonometry function? So a function is simply something in math where we take some inputs and we get an output, right? So in trigonometry, it's a subset of geometry. We're dealing with shapes and specifically with triangles. And what the trigonometric functions do is they take an angle measure and give us a relation or a proportion of lengths. Now that may seem a little confusing, but I'll explain so it makes sense. So first of all, we're going to be using this triangle here as an example. As you see, we have side lengths labeled A, B, and C, and angle measures labeled X, Y, and Z. These trig functions work for any triangle, so it doesn't matter what the values here are. These relationships are always going to remain the same. So we went over the S, C, and T already, but what are the rest of these letters in SOHCAHTOA? These describe the sides that that the trig function finds a relationship between. So defines the sine function, and what it stands for is sine equals opposite over hypotenuse. Okay, so what does opposite and hypotenuse mean? Each of those refers to a side of this triangle, a side length. Now, which one depends on which angle we are finding the sine of. We can find the sine of our angle measures for angle X, Y, or Z. Any of them work. For our first example, we'll use angle X. So if we're finding the sine of angle X, that equals opposite, so the side opposite our angle X is here, the side opposite is C, over, again I said this is a proportion, it's a relationship, so it's always over, H is hypotenuse. Now what's the hypotenuse of a triangle? It's the longest side that is opposite the smallest angle. So in this situation, our smallest angle here is, it's our longest side. It's opposite our angle Y here, which gives us B. So this represents sine, so, S-O-H, sine of X is opposite C over hypotenuse B. We could find sine of any of these angles, and we would get different relationships of side lengths A, B, and C. So this defines sine, so cosine, the next trig function, is defined by ca. That's very similar to sine. All it means is cosine is adjacent over hypotenuse instead of opposite. So if again we take angle X as our example, we can write cosine of angle X equals adjacent. So now we're not talking about the opposite side, we're talking about the adjacent side. And you may think, oh, well, angle X is in the corner here. There are sides adjacent to it, both A and B. How do we know which one it is? Well, as we saw here, we have an H that stands for hypotenuse. So whenever we're talking about opposite or adjacent, that's not going to refer to the hypotenuse. That's sort of how we can eliminate that. So if we say X, okay, we want to use adjacent, but which one is adjacent? Is it A or B? Well, B, we've already established, is the longest side. It's the hypotenuse. Longest side across from the largest angle. It's the hypotenuse, so it can't be B. So instead, it is A. So our cosine of X would be adjacent A over hypotenuse B. Finally, we have our TOA, tangent. This is our last trig function. This one is unique because, as you can see, there's no h involved. We aren't using the hypotenuse at all. Instead, we're using opposite over adjacent. So we found our opposite here in sine, we found our adjacent here in cosine. Here we're finding the relationship between those two. So the tangent of angle x will be opposite C over adjacent A. All right, so this is the definition of our trig functions. So as I stated in the beginning, right, each of these we put an angle measure into the trig function, and we get back one side length over another side length. Now, you may be thinking to yourself, what do we actually do with all this? You know, it seems seems a little abstract, right? Well, we can use this information to find side lengths and angle measures of a triangle when we don't have them all written out for us. We're going to talk through a problem briefly to show how we can apply these SOHCAHTOA methods to actual math problems.